Hello viewers and welcome. In this video we'll be looking at and putting together the CNC kit that I've ordered. I've had some pauses in my video schedule lately. I've got the coronavirus again and that took me out for a few weeks. Perhaps you can still hear it in my voice. My nose is a bit stuffy, but looks like I'm back in the game, and hopefully there's gonna be more videos coming soon. But today we'll have a look at the CNC. First, we're gonna have a look at the CNC set that I've ordered. I've ordered the Vevor 3018 Pro. I very much intended from the beginning to modify this machine and get a better spindle, better Z-axis, and other things, which is why I decided to go with basically the cheapest model that has the basic functions that I'm not paying for anything extra for those things that I plan to upgrade anyway. So the kit comes with a pretty nice set of instructions. I'm not gonna film the whole build step by step, but it is very good, and the English is also very nicely translated here, so it seems to be a good set from a builder's perspective. So let's look at what the set actually includes. First of all, here is the plate itself. It's aluminium extrusion. These are the rails for the x-axis. Or perhaps I shouldn't say rails, but the kind of gantry. Here are the lead screws for the X and Y axis and some of the linear rods. And here is the rest of the kit. First of all, I'll go through what I will be using from the kit. So I will be, of course, using all the hardware and the kind of screws and things as needed. I will be using the power supply for the unit itself. This is the EU plug, since I'm in the EU. I ordered this from AliExpress. There was an option for UK, US, Australia, and EU, so you can select the right, and it will come with the right plug. There's a brush there. I will be using the controller. So this comes, the Vevor comes with what they call an upgraded controller. So it's a slightly clearer screen, I guess, and some buttons. So this is the offline controller, is what they call them. So you can control the device, for example, move the spindle, start the CNC jobs from an SD card and so on, completely without connecting it to the computer with this offline controller. Some cables for it. There is a USB stick. Sorry, this is a SD card reader. Yep. And then this is the brain box itself. Basically, it runs Gerbil, and that's what drives the machine. I will be using that as well. Here are some more hardware. Most of this I will be using. And the plates that hold the gantry from the sides. These are some kind of hard Bakelite type composite material, not metal. It looks kind of like aluminum or aluminium, but it's not. It's some kind of some kind of plastic type material, but it feels pretty hefty and sturdy. I will be using those to hold the gantry. I will not be using these. These are the bushings for the linear rods. I have an upgraded set of these. These are the stepper motors for the axes. I will be using these. They're perfectly fine for moving the bed and the X and Y axes, side to side axes. They're fine for that. Here are the plates for the back and the front of the frame itself. They're the same Bakelite material. I will be using them. And here's some more aluminium. I think this is called 2020. So it's 20 millimeters by 20 millimeters extrusion, which is part of the frame. And some more hardware. And there's a set of end mills here. Very small end mills. I, of course, will be using this as well, at least to start and practice. Then let's go through what I won't be using, which is mainly this. This is the standard spindle and Z-axis combination. It's all plastic. So the spindle here is obviously metal, but and so is the lead screw and those kind of things moving it. But the rest of this is plastic. And I've seen a lot of videos showing that when it's moving, this flexes quite a bit. You can kind of see it here. So I won't be using any of this. There's also the stepper motor for the Z-axis, moving this up and down. I will not be using anything from here. So let's have a look at what I will be replacing that with. So first of all, here is my new spindle. The one that comes with the 3018. It doesn't matter if it's the Vevor one or one of the other manufacturers. They're all the same. The spindle, you can see the size difference here. That small thing right there, that's the entire original spindle. It's, I believe, a 75 watt motor. Could be slightly larger, but anyway, it's tiny and small. I plan to machine mostly aluminium, so I wanted something much more powerful, which is this. This is an 800 watt spindle motor with a fully aluminium bracket to hold it in place. It's also substantially more heavy than the standard one. And to drive that, we have a dedicated motor. So this is a motor driver, I should say, rather than a motor. The spindle obviously has a motor for itself, but this is the power supply and the driver for the motor. So you connect the wall power, so it's a 220 volts where I live. So you put the power there, you put the motor cables here, and then you control the speed manually from here. There is also an option to control the speed with the electronics from the CNC itself. I might go that route, but I will start with the included potentiometer which controls the speed with the driver. So that's going to be the spindle. But when we look at the Z-axis itself, it's pretty flimsy, and there's no way that this will hold up here and work in a stable way. So there's something else. This is it here. This is an all-metal Z-axis. It includes a much larger stepper motor. It's almost 1.5 times the size of the standard one. It also includes a manual wheel, and the stepper motor will attach directly here. Everything is much more sturdy. This will not move around, and of course it's much more heavy. There's a attachment plate to fit different types of spindles. Mine fits here. And it also includes a set of all metal linear rod guides instead of the plastic ones that come with the kit. In addition to that, I have a set of different size collets for using different sizes of end mills. And I have a bunch of high-speed steel end mills as well. These are not probably the best quality, they're Chinese, but there's a lot of them and they're cheap, so it's an easy way to practice. So next up, we're going to be putting this together. First off, we put the side pieces of the bottom frame together and insert the T-nuts and prepare the lead screw. When the bottom frame is complete, the linear rods are in place and the lead screw is attached, and it's ready to accept the build plate. The build plate is now in place, as well as the right hand side gantry support. We are ready to put on the X-axis. And here everything mechanical is installed. The X-axis is in place, and both of the supports for the X-axis gantry are fastened. Here's the backside of the Z-axis. Everything is metal. There's a little bit of fiddling around to put all the T-nuts in place and to be able to tighten the screws, but otherwise everything fits like a glove. Let's try the manual jog wheels, Y-axis. Moves smoothly in both directions. The X-axis. Same thing here, moves smoothly in both directions. And finally the Z-axis. Same here, moves nice and smooth. Here are the electronics. They're fixed on the back. I've connected just the stepper motor cables there for the moment. So now it's time to turn it on for the first time. It's upside down. Let's turn it around. So there is a warning there to make sure you are not connecting the USB connection to a computer at the same time as the offline controller. Let's try it out. We'll try to move each of the axes in a very small increment to make sure everything is working correctly. We'll start with the Z-axis. Looks like it's working fine. We're using 0.1 millimeter increments to start with. Let's change the scale to 1 millimeter. Yep, works fine. 1 millimeter increments, no problem. Let's move back to 0.1. For the other axis, next to Y, 0.1 seems to be working. Let's try 1 millimeter next. Yes, everything looks fine. So the Y-axis minus is moving the build plate back. Let's go back to 0.1. And finally, the X-axis. Looks like it's working. Let's put the 1 millimeter there. We can see more clearly that it's turning perfectly without any problems. There's the button for the spindle, but we haven't got that connected yet. Everything looks fine. Perfect. So my impressions about this build were very positive. Overall, I think Vevor makes a nice product. I'm especially happy with all of the instructions. They are very clear. It's not at all like building electronics things. It's much more like putting together IKEA furniture. Everything is included. There are the different hex keys for all the different sizes of hex screws, and everything is presented step by step in the build guide. So very simple to do. Similarly, the Z-axis upgrade is including absolutely everything to fit it, and it fit nicely exactly to this 3018 kit. There's no modification or anything necessary. The only thing is that doesn't come, the Z-axis upgrade doesn't come with any instructions, but it's simple enough that things can kind of only go in one place. What I would do um, as an improvement is to use more standardized parts. So for example, there are 18 millimeter and 20 millimeter long hex screws, and it's easy to put them in the wrong place if you don't have if you don't have something like a set of calipers to measure them with. I did that mistake in the beginning, not a big deal. I just took them out and swapped them over. So the thicker Bakelite parts need slightly longer screws to go through them compared to the thinner Bakelite parts. It would be easier to just use the 20 millimeter screws everywhere to make it easy. Same thing with the different hex bit sizes. I think there are a total of 6 different hex keys that you need to use here. If I would build this from hardware store parts, I would obviously use 1 or 2 rather than 6 different sizes, but that's a very minor thing. Everything else fits very nicely, and it's a easy set to put together. I would recommend it. I know there are other manufacturers like SainSmart or Genmitsu. I think one of them is the company and one of them is the name of the product, but it looks like they have a slightly more professional product compared to the Vevor and the more generic ones. It's a slightly more expensive product as well. Probably if you are not planning to upgrade anything, I would go for that. It's not much more expensive, but you get some slight benefits like acrylic side panels on the side, and the presentation of the electronic parts are better in the back. They are inside a box, whereas here on the Vevor and the other more generic models, they are just exposed. But that was fine for me because I planned to attach all the electronics separately anyway to a box outside of this. So this was the right choice for me at this point. Other than that, um, everything seems to be working nicely. And in the next video, we're gonna be putting the spindle controller on and actually trying to engrave something with this thing. Thanks for watching. See you next time.